The topic of this video is simplifying rational expressions. We need to do a little bit of background knowledge before we begin to simplify a rational expression. So let's look at what actually the definition of a rational expression is. It says it's an expression of the form P over Q, where P and Q are polynomials. So it's just a polynomial divided by a polynomial. Now there's a problem when we begin to talk about rational expressions, and that has to do with the domain of the rational expression. Because there can be a variable in the denominator, let me give you an example. 3x squared plus 2x minus 6 all over 3x minus 5. That's a polynomial in the numerator and a polynomial in the denominator, so we call that a rational expression. But the problem occurs with the variable in the denominator. So it says the domain of a rational function consists of all real numbers except those that cause division by 0. These exceptions are called the domain restrictions. So I think it's going to be easier to understand to look at an example. So let's look at example 1a, where we have a function defined f of x equals 3 over 7x minus 14. Now, we know that it is not possible to divide by 0. That is an undefined expression. So if there is a value that x could take on that would cause the denominator to become 0, then that would have to be a restriction on the domain of x. In this case, it's fairly easy to see what I would put in for x that would cause that to become a 0, and that's 2. So what we would say is x cannot be 2, because if it is, we have a 0 in our denominator. Let's look at one where it's not easy to see. So in example B, I have a function defined as g of x equals 3 plus x over x squared minus 4x plus 3. It's very difficult to look at this denominator and see what value of x is going to cause it to become equal to 0. So when that happens, and you can't tell just by looking, what we do is we set the denominator equal to 0, and then we use the 0 factor property to figure out what it is that x can't be. So what I'm going to say is I'm looking for factors of positive 3 that combine to make negative 4. That's going to be negative 3 and negative 1. They multiply to make positive 3. They add to make negative 4. So I'm going to say x minus 3 times x minus 1 equals 0. So note again, what I've done is set that denominator equal to 0. I'm going to finish that 0 factor property by setting each of those factors equal to 0. And solving, and what I get is when x is 3 or x is 1, I end up with a 0 in the denominator, which is not allowed. Now let's kind of verify that. Let's verify 3. That would be 3 squared minus 4 times 3 plus 3, or 9 minus 12 plus 3. Yeah, that makes a 0. So x cannot be 3. Now let's verify the 1. That would give me 1 squared minus 4 times 1 plus 3, or 1 minus 4 plus 3, which also gives me a 0. So x cannot be 3 or it cannot be 1. Those are restrictions on the domain of x, the things that x can be. So the domain is what x, let's write this up here, can be. The domain restrictions are what x cannot be, because it would cause division by 0. Now I want you to notice, in this example, there was an x in the numerator. That's fine. You can have, I could have x be negative 3 up here. 3 plus negative 3 is 0. You can have a 0 in a numerator, no problem. You just can't have a 0 in the denominator. So that's the only thing that we're dealing with when we talk about a restriction, is just the denominator. Let's look at this next one. It says the function h of x is equal to 8x plus 2 over 3, and we want to know what is the domain restriction. Well, because the domain is always going to be equal to 3, there's no variable in that domain. There's no way that I can get a 0 in the denominator because it's always going to be 3. Remember, it doesn't matter what the x in the numerator equals. So we would say there is no domain restriction for this function. There's no way we can get a 0 in the denominator. Okay, let's look at this next part where we're actually going to be simplifying. It says to write rational expressions in lowest terms, factor both numerator and denominator and cross cancel. I'm saying cross cancel. We're really marking off forms of 1, but you're familiar with that term, cross cancel. So let's try one of those. And the main thing that you need to remember here is you cannot cross cancel parts of a numerator or parts of a denominator until it's been factored. So factor first. So here I can't cross cancel this y with part of that y, or those 4's, because this is a unit and this is a unit. So what I have to do is get it down into factored form. So y squared minus 4 is an example of difference of squares, so it's y plus 2, y minus 2, over here I'm going to factor out the GCF of 2, and I'm left with y plus 2. Now notice I factored both the numerator and the denominator. Now I can cross cancel factors, not parts of an expression, but actual complete factors. So y plus 2 over y plus 2, and this simplifies to y minus 2 over 2. The 2's cannot cross cancel because the 2 in the numerator is part of a unit. All right, let's look at this one. I need to factor first. I can't cross cancel those a squareds. Don't even try it because it's not going to work, or the a's or the 6's, because it's part of a unit. And what tells you that is the minuses or the pluses like we have here in between. So let's factor this numerator. It's a trinomial shortcut process, so I need factors of -6 that combine to make -1. That's going to be -3 and +2. So x minus 3, x plus 2. Here, again, I have a trinomial shortcut, so I need factors of +6 that combine to make +5. That's +3 and +2. So that gives me x plus 3, x plus 2. Now that everything is factored, you may cross cancel factors. So x plus 2 over x plus 2, and I'm left with x minus 3 over x plus 3, and you cannot cross cancel any of those parts because of the plus and minus in the numerator and denominator. Let's continue to simplify some of these, looking at example C. Here I have x cubed minus 27. We did sum and difference of cubes in a different video, so I know that for cubes I have a short parentheses and a long one. What got cubed here was x first, 3 second, so it goes first, second, first one squared, multiply them together, second one squared, and then we go same, opposite, always positive. So now that is factored. My denominator here doesn't need to be factored. It already is factored. X minus 3. That's as simple as it gets. But I can cross cancel those two factors, and I'm left with x squared plus 3x plus 9, which is not factorable. Looking at D, I see 1, 2, 3, 4 terms. I hope that triggers you to group. So in my numerator, I'm going to factor out the GCF of the first binomial, which is R, and I'm left with P plus Q. Now I'm going to factor out the GCF of the second binomial, which is s, and I'm left with p plus q. So my numerator, let's do the numerator right here, is going to factor into p plus q times r plus s. Now we're going to do the same thing in the denominator. I'm going to do it with a different color so you won't get that all blended together. So here I'm going to group and group. There is a negative in between. I make a correction right there. And I have the GCF of that first binomial is r. I'm left with p plus q. The GCF of the second is s, and I'm left with p plus q. So my factors are p plus q times r minus s. And now we can see that everything is factored. I can cross cancel factors. So p plus q over p plus q, and I am left with r plus s over r minus s. One last thing I want to show you here. It says, note, if the numerator and denominator of a rational expression are opposites in subtraction, like x minus y, y minus x, then the rational expression is equal to -1. I'm going to go over here, down here, kind of, and show you why. If I had 5 minus 3 over 3 minus 5, those are opposites in subtraction. That would give me 2 over -2, which is definitely -1. But if I had 5 plus 3 over 3 plus 5, those are opposites in addition, and it doesn't make any difference because I still get the same answer. That is equal to 1. So the thing with being opposites only works in subtraction. So let's simplify these by factoring first, always. I'm going to write that again. Factor first, then cross cancel. All right, the numerator is difference of two squares, so it's r plus 4, r minus 4, and the denominator is 4 minus r. Now notice, r minus 4, 4 minus r. They are opposites in subtraction. So I can cross cancel, but it makes a -1, not a +1, and so you have to write that. I think the safest thing to do is leave your answer as -1 times r plus 4. That's the safest, but of course you could distribute that -1 and get -r minus 4. It's the same thing. Let's try this one. Again, in the numerator I have difference of two squares, so it's going to be 5z plus 4 times 5z minus 4. In the denominator, I don't have difference of two squares. Neither one of those are perfect squares, so I'm going to factor out a GCF of 3. That's going to leave me 4 minus 5z. Notice, 5z minus 4, 4 minus 5z. Opposites in subtraction. Cross cancel them, but leave a -1 in their place. So it's going to be -1 times 5z plus 4 over 3, and that is the safest way to write the answer without distributing or doing anything else, just leaving it like that.